G'day, you 9. Let's get on to our next bit. This is simple quadratic trinomials, the start of some really exciting and important stuff. The first point to make clear is the word tri. Tri, of course, means 3, so trinomials, as you can see here, have 3 things. An x squared, a constant x, and then a number by itself constant. So x squared, 5x, 7 is an example of a quadratic trinomial. Now, it is called a quadratic trinomial because the highest power of x in this trinomial is a 2. Now, you might be thinking, doesn't quad mean 4? How is 2 a quadratic? Well, because power of 2 means squared, and when you square, obviously squares have 4 sides. So square is quadratic. And trinomial, tri means 3 things. Okay, let's move on. Alright, so write these down, please. Let's use FOIL, as we've done previously, and expand each of these and collect like terms. So have a go, and we'll go through it. Okay, so x squared plus 5x plus 3x plus 15, x squared plus 8x plus 15, x squared minus 3x plus 8x minus 24, x squared plus 5x minus 24. Remember what we're doing. We are using FOIL. This times this, this times this, this times this, and this times this. So 4 expansions. Question 3. X squared minus 4x minus 7x plus 28. Again, minus is plus. X squared minus 11x plus 28. Okay. Now look carefully at each of these and the answers you get. What do you notice about the coefficient of x each time? Notice it's x and not x squared, and coefficient is the number in front of your x. So look carefully. Look at the numbers here and the coefficient of x. What do you notice? Pause the video and have a look. You can probably see that in each time, 3 and 5 is 8. 8 minus 3 is plus 5, minus 7 minus 4 is minus 11. So there's a bit of a pattern emerging between the numbers here and the middle term. Now this bit here, what do you notice about the constant term each time? As in the number at the end in relation to the numbers in here. Again, pause the video and have a look. You can probably see that you're now multiplying those two to get to that last term. See that? So these two multiplied gives this, and these two plus gives the middle term. Can we all see that? Let's make it official and write it down. So first part, we're adding the numbers. So numbers in brackets are added. And the constant term, which is the last term, numbers in brackets are being multiplied. Okay, so this, and this, they expand to this. In today's lesson, we're going to learn something entirely new. We're going to go from here back to the brackets. And of course, that is called, starts with F, factorizing. Let's keep going. Okay, write down this heading, please. Factorizing monic quadratic trinomials. Again, star 5.3. Now this word monic, what does mono mean? Like monorail. Mono means 1. So monic means all the squared bits, there's a 1 in the front. So 1y squared, 1m squared, 1x squared, 1a squared, and 1t squared. Later on, we might have, say, 4x squared. That's a non-monic trinomial. Okay, so write down the first one. Question 1. Y squared plus 7y plus 12. So we're going to factorize this back into what we had on the previous slide with 2 brackets. Now, there are a few ways of doing this. Technique 1 is the cross method. So we're going to draw a nice big cross, like so. We're now going to split this, the y squared, into 2 parts here. The only way you can split y squared is to make it y and y. We're then going to split 12 into two parts here. Now we have a few choices. We have 4 and 3, we have 12 and 1, we have 6 and 2. Which of those do we choose? Well, the important part is that when we pick a number, the cross, we must be able to move through the cross to get the middle term. So I'll explain what that means now. So for example, to get 12, we can do 4 and 3. So 4 times 3 is 12, which is good. Now when we move through the cross, y times 3 is 1 is 3y. Okay, and then 4 times y is 4y. Can we see that 4y plus 3y is 7y? So when we split up the 12 into two numbers, we must be able to move through the cross, and this times this times this, the two answers here must add to 7y. Once they work, our answer is just literally right here. 4y plus 3. Now just to clarify on the side, why we can't use, say, 6 and 2 to give us 12. If we did that, we'd be getting y times 2, which is 2y, and y times 6, which is 6y. But because 6y plus 2y does not give us 7y, this is not my answer. Okay? So this is wrong. Another way you can solve the same question is the product sum method. I might just do it up here on the side. So y squared plus 7y plus 12. The way product sum works is this. It's very similar, but you don't draw across. Our last number is my times number, and my middle number is my plus number. Now I've got to think of two numbers that times to give 12, and those same numbers add to give 7. And they, of course, are 4 and 3. Once you have that, our answer is just y plus 4, y plus 3. So 4 plus 3 is 7, 4 times 3 is 12. Okay, now from this point onwards, I'm actually going to use the cross method. It's more versatile for questions later on. Okay, so question 2. Let's start by drawing up a cross. Now remember, m squared goes here and here. All we can have is m and m. Now the fun part. Two numbers times to give 6, but when we put them here, we must add to this middle term here. And I believe minus 3 and minus 2 should work. We can check that. Minus 3 times minus 2 is positive 6. M multiplied by negative 3 is negative 3m. M times minus 2 is minus 2m. Negative 2m plus negative 3m is, of course, minus 5m. Once they work, my answers are literally just this. So equals m minus 2, m minus 3. And if in doubt, if you expand it, you should go back to the original question. Pause the video, have a go at question 3. Okay, question 3. Again, drawing across, x squared, x and x. Now, minus 2. I believe that's minus 1 and 2. We can check that. X times minus 1 is minus x. X times 2 is 2x. 2x minus x is x. So these are my answers. And a useful point to realize as well that if the last one is minus, only one of these is minus. Looking at question 2, If the last one is plus, both these are minus, or both of them are plus. Because remember, plus plus is plus, minus minus is also plus. Question 4 time. Let's draw a nice cross again. Oops, don't want that one. A. In terms of numbers, again, I need -7, and you get -6 for my plus. I believe -7 and 1 should work. And again, we can check that. A times -7 is -7a. A times 1 is a. A minus 7a is -6a. 1 times -7 is -7. So my answers are just here. So equals a plus 1, a subtract 7. Okay, last question for this bit of work. So question 5, t squared minus 2t plus 1. Again, same deal. Nice cross. T squared, t. Two numbers at times to give 1. Now this is +1, which means these are both minus or both plus. But since this one's minus, these are both minus. Again, just to clarify, minus times minus is plus, minus plus minus will give us minus. So this is correct. But just to put it beyond doubt, t times -1 is -t, t times -1 is -t, -t plus -t is -2t. So my answers equals t minus 1, t minus 1, but of course, same bracket twice means this squared. Okay, so that's the end of factorizing Monic trinomials. Again, this is entirely new, so feel free to replay the video again. But yeah, draw a cross, split the first part on the left. On the right part, you want to multiply to get the last number, but at the same time, when you move through the cross, you must get that middle term. And what's great about these, every time, if you expand your answers, you should always go back to your original question again. Okay, so we'll build on this in future lessons. Thanks for watching, and I'll see you in the next video.